Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will be discussing another amazing content with respect to binary search algorithm. See, in DSA, I always say कि binary search is one of the most important, topic with respect to interview perspective. Whenever you're going for an interview, chances are very high that directly no one will ask you about binary search, but definitely they will ask you indirect questions where you will observe that binary search is applicable. But before jumping towards that part, first of all, thank you so much for everyone for making 10K subscribers on my YouTube channel. And it really means a lot to me. I really want you guys support in future as well. And let's target now to reach to 50K very soon. With this, let's try to understand first of all binary search, followed by the questions with respect to that. It's a recording of, you will observe my paid DSA 2.0 bootcamp or the course, you can say. If there is anyone who is interested to enroll into this specific course, you can join now also. You will able to get all the live session recordings plus the content which I am uploading every week. People are really enjoying it, and what kind of questions we are covering up, how the focus is going on, everything you can see here in this recording part. And if you feel that it will be really helpful for you as well, please don't hesitate to reach out to me. My email ID is mentioned in the description if you have any questions, and you can enroll it as soon as possible. With this, let's get started. So let's start our discussion with respect to binary search. Have you understood the core idea behind how binary search works? Everyone. Is that idea is clear? How the concept of binary search works?
Yes.
Okay.
Yes.
So I will give you a brief context for those people who are new and have joined maybe just now this specific course. So I will give you a brief idea, and specifically for those people uh, who are not aware or who have not watched the recordings. So just a brief idea, and then maybe we will try to solve few questions. Already, I think in the recorded sessions, I have solved few problems with respect to binary search. I'll not repeat those problems because then there is a repetition of content itself, which I don't want. I want to give you in the live sessions extra content apart from what we have discussed in the recorded sessions, right? So, just a brief overview how this searching algorithm works and why this is more beneficial as comparable to linear search, right? So, first thing and foremost thing is that this approach of binary search is applicable only if we will be having a sorted array. This is what I think everyone must have observed when they are studying this part, right? Sorted array means that either your data or array is arranged in a descending order, or it is arranged in an ascending order. Any one of them. Either it will be arranged in ascending order or descending order. For example, let's assume that we will be having a sorted array available with us. Let's assume the array contains elements like 10, 20, 30, 40, 50, 60, 70. So here if you can see, we just have 7 elements. Index number we have seen in arrays data structure, by default it will start from 0. In the previous live session also, I have talked about the concept of 0 indexing and 1 base indexing. What's the difference between these two? Conceptually both are same. The only difference is by default it will start from 0, but there the assumption is that we are starting from 1. That's the only difference. Now let's assume that we want to search for element like 50. So means 50 is the target element that we have, which we want to search for. So how this binary search algorithm works, it will first of all try to find the value of a middle index, which is what the value of a lower index plus the value of a higher index divided by 2, or you can say lower index plus higher minus lower index divided by 2. Any one of the ways. If your data size is very, very huge, use the second approach, low plus high minus low by 2, so that there will be not overflow condition which will happen. I have already explained in the live sessions in the past part that what's the purpose of that, so you can watch that session. I'm not going in that much depth, but that's the main intuition behind the same. So here, for easier calculation purpose, I'm just using low plus high by 2. So you can see here the mid index is something which we will be able to get as 3. So what is happening is we will be able to get an understanding that target is 50 and the element which is available at air of mid is something which is equals to 4040. Now what will happen is we usually try to compare this current element with the target value. So what we will do, we will say, we will apply one while loop and we will say until my value of low is less than the value of high, do one thing. And what is that thing? Simply, first of all, try to evaluate the value of mid, which is low plus high minus low divided by 2. After that, I'm just writing a pseudocode. Don't expect to have a proper syntax or indentation here. It's just for the reference per se I'm writing. We will try to just compare what is the value of air of mid and is that value is equal to target or not. For example, if let's say it is equal, in that case, we'll directly return the index number, which is mid, right? For example, if let's say target is 40 itself, so what we will do, we will return this value of mid as 3 itself, right? But that's not a scenario in this specific case. Means in the LF condition, if let's suppose my value of air of mid is smaller than target, which is what is happening currently, because my value of air of mid, which is 4040, is somehow smaller than the target value, which is 5050. So in that case, what we supposed to do? That is the main thing, and I don't want anyone to cram here. Just think logically. Our array is sorted, and we know that target value is somehow bigger than the value of air mid. So does that value will be available towards right side of 40, or that value will be available at the left side of 40? What do you think?
Right
Well,
side.
it is the right side.
I hope no one is cramming here. It's a very logical intuition that our array is a sorted array, and we are in a situation where we are saying the target that we are looking for is bigger value than the array of mid value. So I am 100% sure that it will be available towards right side of mid. So if I'm saying right side of mid, which parameter I supposed to change? Initially, my parameter of low is equal to 0 and my parameter of high is equals to n minus 1. So what is the parameter which we supposed to change in this case? And with what
Low.
value? Low is equals to
Mid plus 1.
mid plus 1. Mid plus 1. And basically this provides me an idea that you have to go towards the right side search space. Otherwise, if the case is vice versa, where array of mid is bigger than target, then what we supposed to do? Obviously, we will go towards left side by updating the value of high as mid minus 1. Simple. Right? So here, if we will just continue our discussion, and in this specific case, which we are discussing for now, test case, target is 50, so we have to update the value of low as mid plus 1. So what will be the value of low? It will be 3 plus 1, which will be 4. The value of high will remain the same, which is 6. Now what will happen? Again, it will try to evaluate the new mid value, which will come out to be 5. Everyone agrees with me? Because now the new value is low, new low value is 4, new high value is 6. So what is the value of a mid? Can I say it will be 5? Does everyone agrees with me? Yes or no? Till so
Yes.
far, okay?
Yes. Yes.
Okay. Now, again, we will compare. Is my value of r of mid, which is currently 60, and my target, is that same?
No.
So what will happen? Now tell me. What will happen? It will go to the below condition. Is my value of r of mid and my target, is it true?
No.
No. So it means it will go to the third condition. Can I say, everyone? It
Yes.
means that the value of high will be updated now, which will be mid minus 1. What is the new value of mid? What was the new value of mid? Can I say it was 5? So when
Yes.
I'm saying mid minus 1, what is the value of high now? Can I say it will
4.
be 4? Correct. So now what is the new value of mid? What is the new value of mid?
50.
Huh? New value of index number. It will be 4. Can I say? 4 plus 4 minus 4 by 2. So it will be 4 only. Now, again, it will compare. What is the value of r of mid?
That is 50.
It is also 50. So now in this case, it will return that mid. So can I say that now we got the element which is equals to 4. And this is the final result which we will return. Is this correct? And this is true, right? Target is available, 50 is available at index number 4. This is how basically the binary search algorithm works. This approach is something which we called as divide and conquer approach. This is a separate module which we will cover up in our upcoming sessions as well. But this kind of approach is something which we call as a divide and conquer. And yes, binary search is an application of this approach itself. In a lot more detail, we will cover up about this specific module in the upcoming weeks. But anyhow, is this approach, is this algorithm is pretty much clear to everyone?
Yes.
Yes.
In order to use the binary search, should the list will be sorted compulsory? Yes, correct. You only assume that if, let's say, we will not have a sorted list, we will not have a sorted array. So can we decide in that scenario as well that whether we should go towards left side of mid or right side of a mid? Think over it. If, let's suppose, I'm having a highly unsorted array, for example 40, 10, 20, 15, 60, 55, and let's suppose I'm looking for an element maybe 15, let's assume, or maybe, let's say, what could I say, maybe 40, 40. Okay. Now what will happen? 0, 1, 2, 3, 4, 5. What is the value of a mid? It will be 0 plus 5 by 2. So it will take the, let's say, upper bound 3. 15 is there. Now what will you do? You will compare that value of the target. It is not equal. Now how will you decide if the array is not sorted, that whether we should go towards right side of a mid or left side of a like left side of a mid if the array is not sorted? Think over it. Can we decide in this case? Because we don't know that all the elements are bigger towards left side or right side. Array is not in a sequential ascending or descending manner. So that is where the complete logic of binary search fails. So it is really, really important. Because why it is important? I am telling you the core intuition behind the same. Because that sorted array only helps my binary search algorithm to reduce the search space by half, by 2, by 2, by 2, by 2. And whenever this kind of scenario happens, that is something which I have showcased you in my video of the power of logarithmics in DSA. Please, after this session, whosoever have not watched, please watch it out. In your dashboard, it is available. It's not of a very big duration. I think 10-15 minutes of the video is there. Please look into it. So always remember, in a logarithmic, uh, in any algorithm, whenever you will feel that your array is kept on dividing by 2 by 2 by 2, this kind of scenario is a clear indication that you will be having a time complexity of big O of log of n. Is it fine?
Okay.
Make sense? Done till so far? Also, if you want to check it out, the number of iterations which we are running, then also you can check it out. For example, here we will be having 7 elements in total. And if you will take log of 7 base 2, it is approximately equals to, I think 3. You can just check it out. I'm not sure. Let me just do it calculation wise. Exact what is the value? Log of base 2, 7. Yeah, it is coming it as 2.8 something, which is 3. So if you will try to run this code and we'll check that how many number of iterations we are running to get the result, you will observe it is approximately equals to 3 itself. Be it any number, you can extend this number and you can again verify. That is something which we call as complexity. I hope you all remember the concept of complexity. Complexity is nothing but how many number of times a loop is running internally, right? So if you will try to evaluate that, it is nothing but always log of n base 2. Log of n base 2, where n indicates the size of an array. ठीक है? And to get more intuitive idea, please watch that video. I'll not again repeat that same examples and context behind the same. I feel if you will watch that, you will be able to get a better idea. Shall we proceed now to the next important part? Is the
Yes.
binary search intuition is clear to everyone? Shall I proceed?
Yes.
Now, in 1D array, it is fine. Just now we have demonstrated one example. Now, if anyone wants to look for a code part, again, please refer the sessions. I have done in a very, very beautiful manner how the code implementation will be done for a binary search in the Google Colab. Share the file also in the platform. I'll not repeat that same thing. Let's try to do those stuffs which are not available in the dashboard, right? So let's take one 2D array now and let's try to see that can we apply binary search over that. But before that, anyone knows that how the 2D structure will be stored in the memory? I have covered up that, by the way, also in our recorded sessions. I'm not sure how many of you have watched, but those who already have watched and know the context, can you tell me? If let's say I will be having a 2D array, any answers I'm getting?
I mean,
It's kind of a
basically
matrix.
I'm showcasing you. For example, let's take this picture. Let's take this picture and we will try to take this question also now. Let me try to save it over here. So you will be having this specific 2D array. This is called 2D array. What is the meaning of 2D array? Means you will be having rows and columns available with us. So here you can see that we will be having 0th row, first row, second row, 0th column, first column, second column, and third column. Okay? So here we can see that we will be having 3 number of rows and 4 number of columns. So what I'm asking from you all is that do you have any idea that in memory how the structure of this two-dimensional array will be stored?
so it will be stored in row major and column major.
Correct. So I think I have covered up in the recorded sessions this part in detail. Am I assuming it correctly? List of list. Yes, you can say row major form or column major form, you can say. By default, if you will ask me, so by default, it will be stored in the form of a row major form. What is the meaning of row major form? Simple meaning is that it will pick up the elements row wise 1, 3, 5, 7, followed by 10, 11, 16, 20, followed by 23, 30, 34, 60. So what will happen is, although you see that it's a two-dimensional array, in your memory it looks like a 1D array itself, where the storage will done like this: 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, and 60. Is that fine? So what I have done is I have just taken row wise every 4 element and will try to store it in a one dimensional data structure. This is how basically in memory our data looks like. Our data of 2D array looks like. And one more thing, can anyone tell me how we will be able to access any element in a 2D array? For example, if let's say I want to access 16. So how will you access that? For example, we
Of
have
1,
add
2.
Array of
Array of
1,
1,
2.
2.
1, 2. You will provide a row index number. I hope again everyone knows this stuff. And we will provide a
Column index.
column index, right? ठीक है. So it's a in this way it will be stored by default. Again, zero based indexing will be there like this. So this is something which I'm expecting everyone to know, that by default it is a row major form, and row major form means row wise it will take the content, will store it in the memory. Column major means that it will take column wise the elements. For example, 1, 10, 23, followed by 3, 11, 30, followed by 5, 16, 34, followed by 7, 20, 60. But for now, let's assume a default configuration itself. I'm not changing anything here. Now, let's assume what they are saying in this specific case, that the target is, let's say, 3. And one thing they have clearly mentioned, each row is always in a sorted manner, in a non-decreasing order. In other words, it's in an ascending order. And the first integer of each row is bigger than the last integer of previous row. For example, this line says that 10 will always be bigger than 7. 23 will always be bigger than 20, which makes sense also. So indirectly, they want to convey to us that this two-dimensional array is a sorted array. And we have a target value available with us, and that target value is 3. We have to either return the answer as true or false, depending upon that whether that target is available in our two-dimensional array or not. So if let's say this kind of question will be asked from you, how will you respond? How will you answer? Any idea? Any guesses anyone wants to give? What we can do here to perform this calculation?
In memory, it will be stored like a row major form. So this is a sorted, like what I have understood. This is sorted 1D array, so we can apply binary search there.
Yes, very good. So one way could be that when we're talking about a brute force approach, let's start with that only, and then we will move ahead with the optimized version, which is the binary search definitely. So in brute force approach or a naive approach, what we can do is you can say, Priya, what I'll do, I'll linearly traverse all the elements in the array. Maybe I'll apply a nested loop, which will traverse for I equals to 0 to the number of rows that we have, which is m. Let's assume m indicates the number of rows, n indicates the number of columns, and then we will apply inside another loop j equal to 0 till the value of n. And here we just try to compare that if the value of array of ij, because we know this is the way to access any element in the 2D array, if it is equal to the target value, in that case directly we can return true. Otherwise, if we will move out of these two for loops, we can simply return false, because in other words, it indicates that the element that we are looking for, the target element, it is not available in the array. This brute force approach is clear to everyone. So I hope everyone knows this is the way to traverse a two-dimensional array, where what is happening is, if let's say you will be having this array specifically, so what we are doing here in the two dimensions, in the two loops, so we are saying I equals to 0. For I equals to 0, the value of j will run from 0. It will traverse the element 1, because a of ij is 1. Then it will go to j equals to 1. the element will be 3, it will go to j equals to 2, element will be 5, j equals to 3, element will be 7. Then I value will become 1. Again, same thing will happen. J value will be 0, then 1, then 2, then 3. Corresponding elements are 10, 11, 16, and 20. Similarly, when I equals to 2, again this will get changed. J equal to 0, j equals to 1, j equals to 2, and j equals to 3. And for every specific element, our values will get changed. And this is how row wise for the entire 2D array we will be able to traverse with the help of these two for loops that we have. Is it fine for everyone? Any doubts in this part? Anyone? No doubts? Okay. If there is no doubts, what is the time complexity of this approach?
Order of n squared.
N square, you can say if the number of rows and columns are same. But here we are assuming
Order
it to
of
be
m
different.
into n.
Correct. It will be big O of m into n. Can I say everyone?
Yes.
Now, for those who are facing difficulty in terms of how we calculate complexity, it's a week 1 content. I'm again repeating, week 1 is the foundation of all the upcoming weeks. So please make sure you will attempt to rewatch those recordings again. Try to get that understanding that whenever we are talking about complexity, it is nothing but the loops which are going on, and that to the higher loops, nested loops. So that's where it is coming it as big O of m into n, right? Now let's approach towards the optimized approach, where it's quite clear that if we are trying to save this 2D array, which is by default version in a row major form, it's a sorted array, right? And we can definitely apply a binary search over there. But the problem is, our actual array is a two-dimensional form. So we have to somehow map each and every element with the row number and the column number, right? For example, if let's say you are applying a binary search, in the very first step of a binary search, we have to compute the value of mid, which is 0 plus 11 by 2, which is 5.5. Taking the bigger version, it is 6, right? So what I'm saying is that this array of mid is 16. But in order to access the 16, you should know what is its row number and what is its column number. So how can we compute that value? That's the major thing, which if you know, things will be sorted to you. If you don't know, that's a troubling point. Any idea?
So I guess there is a formula. Row into
Okay.
the total elements plus the column.
Okay. Let me write it down. What you are saying, row into
Row into the total number of elements in the array.
total number of elements in a 2D matrix, which is m into n. Then what I do? So basically, to compute any number, row and column, means you have to map it. So the formula is that whatever be the index number you're getting, which is 6 in our case, please focus here, which is 6 in our case, right? So whatever index you are getting, so in the 2D array, its corresponding row index will be the current index number which you are getting divided by n. N is the number of columns. I have already mentioned that. And the column index of that specific number will be the current index number modulus n. This is the formula. Again, I am repeating, and then we will further look into it. What I am saying is, row index is the current index, which is 6, divided by number of columns. For example, for 16, I want to map what is its row index, what is its column index. Then only we will be able to access this element, right? So let's map that. Current index for 16 is 6. 6 divided by number of columns. How many are there? 4. 6 divided by 4. What is the answer?
We can take 1.
1.5.
Yes. 1. So when you are saying double division, it will take the lower bound of that. Okay? It will take the lower bound of that. Then when you are saying 6 modulus 4,
2.
it will be 2. So can you see this map for the row index, this map for the column index? So this is the row number, this is the column number for the element which is 16. Is it correct? Is this
Yes.
correct? Yes. Even I am in the calculation of a mid part will take a double division. So let's take a lower bound only, which is I think 5, and we can map for 11 as well. So can you map for 11? What is the row index and the column index via this formula and evaluate? If let's say the mid value is 5, we will take a lower bound because we will again do the double division only in Python. So if we will take this 5 index, so what is the row index and what is the
Will be 1.
column index? It will be 5 divided by number of columns is 4. It will be 1, and 5 modulus 4 is also 1. That is why you can see at 1 and 1 element 11 is available. Makes sense? Is it fine for everyone? Now, if we will be able to map that, then it is very easy problem. We just have to apply a binary search, get that mid value, map that mid value in the 2D array with the help of information of a row index and column index, and our task will be done. Does that make sense? What I'm trying to convey here? Is it fine for everyone? Is this part is fine? How we are trying to evaluate this row and column index?
Can you explain once again?
I just had a doubt. So first you take the in what do you call 2D matrix and you flatten it, is it? And then you search the index and then use this mathematical operation and then you get the row and column index.
Correct, correct. And this is something which, like the way we are flattening it, it's kind of a virtual array that we have when we are
Okay.
solving this problem. Because in a memory, we know that by default, this kind of a structure we have. We are not writing a code to flatten this array. By default, it is available in our data structure. We know that. It's just that we are using that info, getting that index middle value, mapping that, because we know as a developer, we cannot access any element in a 2D array without information of row and the column index. So we will get that information with the help of this formula. And then we will use this formula to get that exact middle element. And then we will compare. For example, let's say my target is 23. So we will compare. Is that value of 11 is less than 23 or bigger than 23? It is less than, so I will move towards the right side. Same concept, same formula, same logic. It's just that how the mapping is being done when we will solve this. One more interesting thing, when you are trying to curate this 1D array, you should know that the lower index is 0, right? Low value is 0 because when you write a formula, what is the value of low value defined? What is the value of high value defined? So what is the value of high? Can I say it will be m into n minus 1? Think it very carefully.
Yes.
Yes.
Why? M is, in our case, 3, n is 4. Number of elements will be from 4 into 3, 12 minus 1. So index value will be from 0 to 11. So let me just, whatever things I have just now conveyed, write it in a proper code manner. And then if you have any doubt, you can just ask from me. We will try to solve this problem in a very detailed manner before jumping towards next problem. But before that, because this is too much content I have written on the blackboard, might be few things are, clumsy for you in your head. So let me go step by step with respect to whatever content we have discussed so far. I request everyone to open this code editor in your platform as well, in your screen. And whatever things we have discussed just so far, we will try to do the implementation for the same step by step. You just have to follow me and write the same steps one by one. Can we start? Is everyone ready? Or shall I wait for everyone? Let me share the link to everyone. Or you can go to the LeetCode platform and search this problem. You will get very easily. It's a very famous problem. Because everyone knows how we can do searching in a 1D array, but people usually gets confused in a 2D array how the searching will be done in an optimized manner. So that is where we will have to discuss this in a lot more detail. Now, again, today we have learned this thing. When you will document in your editor, in future you will not forget. You will just document it. That okay, row measure form. When we convert, how can we map any element, row index and column index? That's something which I believe for everyone it's new, right? So you have to document that thing. Whatever things are new for you, you have to document it. Otherwise, your brain will not remember that. That's the main thing which I want to convey in every session. Okay. Shall we start? Shall we start?
Yes.
Everyone is
Yes,
ready?
yes.
Okay. What's the very first step which I should do? Anyone who can let me know? What is the first step which we should do? Everyone knows about binary search, right? So what I want is, can you guide me? What is the first step we should start with our code part?
Mid value we
Create the
have to calculate.
virtual array, like get it
Array
into
mid
one.
value you evaluate once you know the value of low and
Low
higher
and high.
index.
Correct.
So shall we first of all initialize those variables low and high? Can we
Yep.
start? So what is the value of low and what is the value of high? That's the main thing. Now, to get that low and high, low to we know it is 0. And high also we know it is m into n minus 1. But the question is, what is m and what is n?
M is number of rows and is number of columns.
Number of rows. So in a 2D matrix, how can we evaluate a number of rows? That's true. So we are defining, you can also comment it down for a better understanding, that m indicates the number of rows we are defining here, and somehow n indicates the number of columns. Now, how can we evaluate the number of rows in this 2D matrix? What is the code I will write here?
Index by
Very
2.
good. Just use len function. If I'll use len of matrix, it will just tell me how many number of rows are there. So this value will return me the answer as 3. Okay? Now if I want to evaluate how many number of columns are there in this 2D matrix, so what I will do, I will take matrix of 0. Matrix of 0 contains elements like 1, 3, 5, 7. And I will evaluate the length of that. And this particular code will provide me the number of columns that I have in a given matrix. Is this part is clear to everyone? So what I'm saying here, I'm again repeating it down. Please try to be very, very awake in this session. Specifically, these DSA sessions required very active brain. So please make sure you are not in a sleepy mood and be very attentive what I'm trying to convey. This is 0, this is 1, this is 2. So when you say length of matrix, it will give you how many number of rows are there. So it will return 3. Now, when you will say matrix of 0, this will create a list of zeroth values, which is 1, 3, 5, 7. When you will say what is the length of that, it will count the number of elements available in this list, which is 4, which is nothing but number of columns. So in this way, whenever you are working with 2D array, this is how you will be able to evaluate the number of rows and number of columns. Does that make sense now? Till so far, good for everyone?
Yes.
ठीक है. Let me remove everything then. and then we will proceed ahead. Now, what should be the next step? What should be the next step to move
We
forward?
calculate the
Shall we
mid.
start with a
While look,
implementation of? So by the way, I am directly doing here optimized approach only. So if you want at your home, you can just do a first approach. It's very simple. So I'm not doing that thing. Okay. I have written the pseudo code for the first approach. I'll share the notes. You can use that and do it. So while the value of low is less than equal to the value of high, what we will do? We will first of all try to evaluate the value of mid, which is start plus, sorry, what is the value? Low plus high minus
Minus low
low
into
divided by 2. Mid is done. What we do now? What we do now? What's the next step? This is the mid index. We want a mid element. Then only we can compare with the target. And it's not a 1D array where we will mention metrics of mid and we will be able to get the result. We need for that mid index, the row index also, the column index also to get that mid element. So how will I get the mid element? That's the next task. So what we will do here to get the mid element?
to find the exact row and column value.
Exact row index and column index value. So how can we get that? We can say matrix of. Okay, let's do one thing to make it more clear. Let's try to evaluate row index. Do you remember the formula to evaluate a row index? What is that?
Mid
It will
divided
be
by n.
mid divided by n, number of columns that we have. What is the formula to evaluate a column index? It will be
Modulus n.
modulus n.
modulus n. Now directly use this variable, row index and column index. Because now we have both the indexes, we can easily access the element of this matrix and that will become my mid element. Now, can we compare this with a target value? So what we can say? We can say if let's suppose my target is equal to the mid element, in that case, we can simply return. क्या return करना है हमें? What is the expected result they want from us?
index. True.
True.
It's a boolean, bool. So we will return true, right? It means that the element is available in our array, 2D array. If that's not the case, in elif, if let's assume my target is smaller than mid element, so what we should do? Think and then speak. If our target which we want to search for is smaller than the mid element, so shall I move towards left side of array or right side of a mid element?
Left side.
Left side of the mid
Target
element.
should be.
Okay. Everyone agrees? Anyone who disagrees and says that no, Priya, we have to move towards right side of a mid? Anyone? You can unmute yourself and just speak it out. No one. It means everyone is saying that we are sure because the target is somehow having a smaller value. Array is already sorted as per the given conditions. So we are definitely sure our target is available towards left side of a mid element. Okay. In that case, what's the variable update we supposed to do? Is it an update of a low or high?
High has to be updated.
With what value?
Mid minus
Mid minus
1. 1.
1. So, sorry, what happened? Mid minus 1. So, it means that in this case, we are exploring the target value towards left side of mid. Otherwise, we need to do the exploring of the target value towards right side of the mid. Means we will write else condition and uh, we'll say, can I write or you will say to me? Low value is equals to
To mid plus 1.
mid plus 1. And finally, if let's say we will move out of this complete while loop, still we won't be able to get any element. We will return simply false, which indicates somehow that the element which you are searching for is not available in your array. Is that fine for everyone? Let's try to run this code and we'll check. You also run your code and check, is everything working fine or not. For me, it's working perfectly fine. Check in your case. Is that working fine? For everyone? Is that working fine? Give me the confirmation in the chat window. Can I get the confirmation from everyone? Sunil, Mayur, Raghav, Gaurav, Rajendra, Burger Parkins, Rashika, Merigu Naresh, Shrikant. Can I get confirmation? Is that working fine? Is it clear? If yes, then we can proceed to the next problem. If no, please ask me a question. What happened? Why everyone is silent?
There are some errors in my code, so I am rectifying.
Is this happening for everyone? That's why you guys are silent? We are trying.
Basically,
Okay.
typo
Indent
errors.
problem
So
is there. Indentation is problem.
Okay. Fix it. I'm waiting for you. Once it is done, give me the confirmation in the chat window. And whatever mistake you have done, again, remember that okay, this is something which I have mistaken, and in future I'll take care of this. Yes. What's the status? Everyone?
Yes.
Done?
Yes.
Account not yet created. Shrikant, why you are doing this thing? Please, guys, please don't do these kind of things. Otherwise, taking this batch will be of no use. DSA will only make sense if you will practice hard these questions. That's the main thing. No one will appreciate your knowledge of having list, stack, queue if you won't be able to implement these questions. That's the harsh reality, but this is what it is, and this is only help you to crack the interviews, right? So please make sure today only, if you don't have an account, create that and solve the problems. I want to see at the end when this batch will get over, how much is the maximum problems you guys have solved from everyone's side. And definitely the student who will be more disciplined and solve maximum problems in an appropriate manner with the proper documentation, he knows genuinely whatever he has done. It's not that he just copy pasted from others code. Definitely that student will also rewarded by me. That is something which I always do for every batch, because I feel for every batch, there are sincere students which will be rewarded at the end of the day. And I really want everyone to be a part of that. I don't have an issue if the students are more. It's not that only single have to be there. So please make sure you will do it. Yes, Raghava, it is correct. It is correct. Shall we proceed to the next question? And before jumping towards that, let's discuss our very last thing. What is the time and space complexity of this code? So let's discuss that part also. Now we know that we are applying a binary search on the number of elements as m into n. So definitely it will be log of how many number of elements you have, which is m into n, right? So this is the overall time complexity of this approach. If we are talking about space complexity, I hope everyone knows space complexity is nothing but how much is the extra space consumption is taken by your code. If you will see, we are not using any external data structure to store the values or to store the results. So that is something which will be constant in this case. So this is how our result will look like at the end of the day. And I'm also saving this specific code part to give you as a reference in my notepad file, right? After the class will get over. Whatever problems we will discuss in the live sessions, I will share the solutions which I have written in your dashboard. Whatever you have written, you have to document in your GitHub profile, whatever I have told just now, few minutes back. Shall we move ahead to the next problem now? Is everyone ready? Or need
Yes.
some time? Any
Yes.
confusion? Okay, yes, perfect. So let me go back to this part. Let's try to solve find peak element. New problem. Let me try to reset this thing and let's focus over here. Next problem which we are solving is peak element. Have we solved this problem in the recorded sessions? Anyone who can give me a confirmation? Search.
I have not seen the full video.
Oh, 2D matrix. Okay, anyhow, solve it, because again, it's a very interesting and important problem based on the concept of binary search. Let's see how can we solve this specific problem as well. Okay. First of all, again, let's try to have a read of this problem in a very detail. We'll try to understand what they want from us at the end of the day, and then step by step, we'll try to get the logic and we'll try to solve it. So what is the meaning of peak element they are saying? So they are saying a peak element is an element which is strictly bigger than its neighbor. Okay. Given a zero index integer array nums, we have to find a peak element and return its index number. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums of -1 and nums of n is negative of infinity. In other words, an element is always considered to be strictly bigger than a neighbor, that then it's outside the array. You have to write an algorithm which runs in a logarithmic time. So let me try to copy this specific part. And first of all, let me try to explain you what they are trying to convey here. Finding of a peak element. So in this specific sheet, if you will be able to observe this two sum, I am writing down a status here. This problem is a part of recorded sessions. For every particular problem which I am mentioning in this sheet, it should be marked as done by you as a status. In your references, I hope everyone knows what problems they are solving. Binary search algorithm, today we have seen how can we do in a 1D and 2D array, both of the stuffs, right? 2D array also I have showcased you with the help of the example of search 2D matrix. So this we have done in a live session 2. Same thing I'm referring here, live session 2. Sort colors I have done in a recorded sessions. You need to just check it out. Repeat and missing numbers is a part of a recorded session. Duplicate numbers, recorded sessions. Product of array, it's an assignment problem, week 1. Remove element, assignment problem, week 1. This is also. By the way, whatever problems, I am writing it down here. All these problems are the important ones. At the end of this batch, our target is to cover up a problem range between 100 to 150 with a variety of portions. And if we can accomplish that, definitely chances are very high that we will be easily able to crack at least maximum companies, right? That's the main objective. To some problem I have covered up in live session 1. One thing is, here I am not taking the very first initial session into account. So let's mark it as the live session 3, live session 3. Because our live session 1 was a very orientation kind of a session where we have just discussed about getting started with DSA, if you remember. So I was not taking into account, but let's take it so that in the dashboard you will not get confused with the session numbers. So this is the live session 1 where we have not done much things. We just introduced each other, and that is where our journey started of main DSA portion, right? So that is where we started our journey, because it's very, very important for me also to see how the batch is going on, right? That is why I am also documenting the stuffs now. Power of an element you will see in the session number 6 where recursion is there. So it's a part of a recorded session. You have to understood this concept very, very carefully. It's not that those are the portions which are recorded sessions will not cover up in the live. We can cover up whatever queries you have, that topics only, obviously not all the topics. Rotation of an array we have covered up in live session 2. If you remember, in the last session we have covered up. Majority element, I don't actually remember, but I feel it's a part of a recorded session. You can just do let me know after this week on Sundays, after Sunday's part. On Monday in the evening, like from 8 to 10 or 11, we will meet again on Monday. So you can just let me know that Priya, is this problem is covered up or not. If it is not covered up, we will take it in a live session 4. which is on Monday. Find peak element. I'm doing it just now. It's a part of a live session 3. Okay? So from future onwards, whatever problems we will be solving, we will always document it. I will keep on updating this sheet, and let's see at the end of the day, in this batch, how many problems we will be able to cater, right? Okay, makes sense. And if I'm missing any problem now in this specific case, you can just give me, in a Telegram group notification that, yeah, this is the problem also which we have covered up, but you have missed mentioning in the sheet when you are watching the videos or doing the assignments. And if you feel that there are more problems which we have covered up, you can just provide me a name of that, and I'll add that problem in a sheet with the portion that whether it's a part of a recorded session or whether it's a part of a live session, because we are doing recorded also and live also. It's a merging of both of them in this batch, so we have to make sure that which particular problem belongs to which specific sessions. Does that make sense? Okay, let's
Yes.
move forward. So now let's try to focus on finding of peak elements, and for that, let's try to copy this specific thing and paste it over here. Mhm. This specific array. What happened? Let me again do it. Okay. So this is the nums array that we have. First of all, let's try to understand that whether the understanding of the problem statement is clear to everyone or not. So here we have a array given to us. You all know it's a by default 0 base indexing, 0, 1, 2, and 3. And what they are saying in this specific case is that you have to find a peak element. Now, what is the meaning of a peak element? Any element whose neighbors are smaller than that element. For example, if you will see this 3, 3's left side is 2 and 3's right side is 1. Can you see that? 3's left side is 2 and 3's right side is 1. So this is something which we called as a peak element. That is the definition of a peak element. Okay? So what is the index of that? It is 2. So they want us to return the output as 2 in this specific case. That's why you will be able to observe the result is 2. So 3 is a peak element and your function should return the index number as 2. Same thing will happen here. You can see 6 is a peak element because 6 left side is 5, 6 right side is 4. 6 is bigger than both of the sides. So that is why it will return the answer as 5. Because if you will see the index number of 6, it will be 0, 1, 2, 3, 4, 5. That's why the answer is 5. One thing which you must have observed here, what they're mentioning is this specific line. I'm not sure how many of you have understood this line, this imagine wala part, what they are trying to convey. They are saying that the element, because when you are doing the comparison, you will compare the left side of every element and right side of every element. But when you are at 0th index, there is no left side of 1. And when you are at last element, there is no right side available. I hope everyone agrees. For example, in this specific array that we have, we will be having elements like 1, 2, 3, and 1, right? These are the elements that we have. These are the elements that we have. 1, 2, 3, and 1. 0, 1, 2, 3. So we know we can compare 2 with 1 and 3. We can get that, okay, 2 is somehow smaller than the right side. That's why it's not a part of a peak element. Same thing we can do for 3 as well. We have left and right for both. But what happens for the extremes? Because one's left is not available, and here in this right side, one's right is not available. So they are saying assume that value to be minus infinity. Means that these extreme values, left and right, will be of very small value. You can imagine that. You can consider that and accordingly solve this problem to find the peak element. Is the problem statement is clear to everyone? Any doubt in the problem statement? Anyone? If anyone is having any doubt, please ask from me.
So the left side of the element has to be smaller, isn't it? Like, or is
Peak element meaning that peak means bigger, means that element, whichever you're calling it as a peak element, it's left also and it's right also, having a value smaller, means that's the greatest value. For example, 3 is the peak element because 3's left is 2, which is smaller than 3. 3's right is 1, which is smaller than 3. That is the definition of a peak element. Is it fine?
okay.
Any questions anyone is having?
Can you explain the given condition?
This condition says that, see, when you will start approaching this problem with respect to the extreme left and extreme right values, with respect to this one, you only have to focus on this upcoming value. That's what indirectly they want to say. You can assume that one's left side is a small value only. Negative infinity is very, very small value they want to convey indirectly. So when you are focusing on this one, just focus on the one's right. And if one's right is also smaller, so you can take it as a part of a peak element. But here it is bigger, so that's why one is not a peak element. Same thing will happen here. So with respect to this one, left and right, you can consider that right is a very small value. So in other words, they are saying that just focus on the right side. Is that smaller than the current value? No, it is bigger. That's why one is also not a part of a peak element. So when you are at the extreme left or extreme right, and you know that its left side and its right side is not available, you can assume it to be minus infinity, means you can assume it to be a very, very small value, and you just have to focus on its neighbor, only single neighbor you have to focus on. And if that single neighbor is having a smaller value than its current value, then you can mark it as a peak element. For example, if let's say instead of 2, 0 is there, so you can mark 1 itself is a peak element in that case, because once left we are considering it as a minus infinity, which is a very, very small value. Once right is also very small, which is 0, so that is why 1 is a peak element. But for now it is 2, so that is why 1 is not a peak element. Is that fine?
I just had a doubt. So, in case I
Hmm.
take the index of 3 as n, so the n minus 1 element and the n plus 1 element should be smaller than 3, right? That's the logic.
If you are taking 3, this 3
Yeah,
or this 3,
3's index is n. The n minus 1 index and n plus 1 index should be smaller than
yes.
3. That's the logic.
Correct, correct. That's the logic. So if you are assuming that, let's say this is the, not say n, because by default we have a habit of saying n as the size of the array. So let's assume if the index is I, okay, for any specific element. So you have to compare I plus 1 and you have to compare the value available at I minus 1. And both of the values, if both the values are smaller than the current index value, then you will call it as a peak element. That's the simple definition of a peak element which they want to say. Is that fine to everyone now? What is the definition of a peak element? So at every point of time, at every iteration, you have to compare its next number and the previous number. If at any point of time you find in the current index the next number and the previous number is smaller, then this current number, which is 3, for example, in this case, 3 is bigger than 1 also, which is the right side element. 3 is bigger than the 2 also. So you will call this 3 as the peak element. That's the definition of a peak element.
For this two-pointer approach will work, right?
For this,
Two-pointer approach.
uh, now that's the question which I want to ask from you. If the problem statement is clear, how can we solve this problem? First of all, give me a naive approach, whatever is coming in your head.
You can take a simple for loop and traverse the area and we can check it.
Correct. We can take a simple for loop, traverse the array, and at every iteration we can just compare. For example, with respect to 1, it's a left side, we will not compare because we are assuming it to be minus infinity. We'll just compare in the extreme part the right value, and in the extreme right value part only the left part, and remaining in between whatever elements are there, we just keep on comparing with the values left, which is I minus 1, and values right, which is I plus 1. At any point of time this condition will be satisfied, meaning the current ith index element is bigger than the I plus 1 and I minus 1. In that case, we will directly return it. What is the overall complexity of this approach? What is the overall complexity of this approach?
Big O of n.
It will be big O of n. Can I assume? Because what we are doing is we are applying a for loop for I equals to 0 to the value of n, and we are just comparing that if the value of I is equals to 0, in that case though we will just compare with the next element. When I am saying I equals to 0 means we are pointing to this specific element. So we are just comparing is the value of r of I. So you can even say directly in this specific condition also, if the I is equal to 0 and the current value of r of I, if let's assume it is bigger than r of I plus 1, in that case I'll directly return that specific index of I as the peak element. Another condition which you can write it as if the value of I will reach to n minus 1, means I am saying extreme right case, this wala case. And the value of r of I, which is for example here it is 1, if let's say it is smaller than r of I minus 1, not smaller, bigger than r of I minus 1. Means what I'm saying is, if let's say somehow we will be having some value, let's say 7, and 7 is bigger than 3, and by default we're assuming the 7's right will be negative of infinity. So in that case again we'll directly return the value as I. In else case, if that is also not the case, then we have to compare both the sides. Means in that case, we are working with the elements which are available not in the extreme rights, but also in the like 2 and 3, where the left is also there, right is also there. In that case, what we have to do, we just have to compare is the value of r of I, means the current element, is that bigger than r of I minus 1, and is the value of r of I is also bigger than the value of r of I plus 1. If both the conditions are true, in that case, we'll directly return that I as the peak element. So that is the thing which will keep on, you can say, we will exploring towards the complete loop, and that is why, because it's a complete for loop, we will keep on iterating towards the end of the array. So it will take the complexity as big O of n, linear time complexity task. Is that part is clear? That's the simple, sorry. That's the simple brute force approach that we have, right? Any doubt in this approach, anyone, before we will proceed to the optimized approach? Any doubt
So
in
we
this
can
approach?
get multiple peaks here. So
Did they have mentioned that we always
yes,
have a single peak element?
no,
So here you can see, if the array contains multiple peaks, return the index to any of the peak. So if they don't care, they will pass your test case. So you can apply this if else condition. If let's say first time itself they will get the peak element, they will get the value, even though we will be having the multiple peaks, don't care. If let's say this will pass second condition and contains a peak element, directly return the value. If let's say both of them won't pass, third pass, it will return that. So if we will be having multiple peaks, that's not an issue for our code. Is that solve your confusion, Mayank?
yes, ma'am. We are just comparing with the names.
Yes. Now the question is, can we optimize this further? Maybe big O of n to fine, but can we write a code in logarithmic time complexity?
We can use binary search, but
Okay.
if we find our mid value which satisfies the peak value condition, it is fine. But if we cannot find, then which way we should have to go?
That is the major question. That is something which we have to think. So, if let's say we are thinking about a binary search, we know that low value, let's take the same array now again. Or maybe let's take some bigger array that we have and let's think over it side by side. How can we solve this? Yes, binary search we can apply, but a major thought we have to give towards left and right exploration. Let's see how many of you will be able to get that idea. So let's try to curate a list over here. 1, 2, 1, 3, 5, 6 and 4. ठीक है? 0, 1, 2, 3, 4, 5, 6. Low value initially will be 0 and high value will be equal to 6. We will apply a while loop where we are saying that low is less than equals to high. We will try to evaluate the value of mid, which will come out to be 3. Now, if the value of mid is 3, so what is the condition you will apply in the pseudocode? So you are saying low comma high is equals to 0 comma n minus 1, right? And one base condition which you can apply is if let's say you will be having number of elements as 1 only. In that case, what is the peak element?
Itself.
That itself. Can I say? Uh, so here, okay, they have not mentioned to consider that case, but anyhow, it would be a best practice to consider the base case also. So can I say in that case, I'll return the 0 index itself because that is only a peak element that we have. If that's not the case, that is the important thing which we have to do where actually binary search will work. Low less than equal to high. So we will evaluate the mid, which is low plus high minus low by 2. That is fine. Now, the major thing which I want to see here is if let's say my mid value comes out to be 0. If let's say my mid values comes out to be 0, what is the meaning of that? For now it is 3, that is fine. But if let's assume it will come out to be 0, because we will keep on updating this low and high value, it might be the case sometime it will go into that constraint where the value of mid is 0. So what will you do in that case?
We have to apply
What is the
that
meaning?
condition,
Uh-huh.
minus infinity, then we have to check that.
Can I say in that case, we just do the one comparison towards right side? Because negative, this side, we are assuming it will be minus infinity, means very small value will be there. So in that case, can I assume I will just compare and that value of nums of mid should be bigger than nums of mid plus 1? Then it is a part of a peak element. Is that first condition is correct? Think over it. First condition meaning I'm talking about this extreme case, extreme left case. If let's assume here it is 0. So can we say 1 is a peak element? Yes or no? Is it
Yes.
fine?
Yes.
ठीक है. Let's move to the second condition. Or, I'm applying a or here. Why? Because any one of the condition will be satisfied, then we will return the answer as mid. Or, if let's assume my condition is if the value of mid is equal to n minus 1, go to the extreme right. If that is the case, in that case, what we supposed to do? What is the
Only
second
check the
condition in
left.
that case? Uh-huh.
Like on the right side will be minus infinity, so we can only check the left side.
Yes. So can I say nums of mid in that case should be bigger than
Mid
nums
minus
of mid minus 1? That is the second condition. Or if both of them we have sorted out, means they are not an extreme case, means they are a part of either this case, this case, this case, this case, this case. For example, mid equal to 3 is a part of between case where it's having a left side also, right side also. So in that case, we have to compare both the sides. So can I say in that case, our value available at nums of mid currently should be bigger than nums of mid minus 1, and the value of nums of mid should be bigger than nums of mid plus 1. That is the condition of a peak element, if I'm not wrong. So I am saying if any of these conditions will be true, in that case, simply return mid. Is it fine? Till so far, is the pseudocode is fine? Think over it
The
and
or
give
are
me a
the elif
conclusion.
conditions, no?
Haha.
The or are the elif conditions will be there.
It's your wish. You can apply a or na directly. It's a logical operator. In bit manipulation, we have seen, right?
Yes.
If in a if condition itself, you can apply 3 conditions, 1, 2, 3. And you are saying if any of these conditions will be true, if condition answer will be true. In that case, go inside the if and return mid. Why to apply multiple elif in this case? Can we do like that? Within one if condition? I think that's that's a more cleaner code as comparable to what you are saying.
Yes.
Okay. Now the major question is, if that is not true, means if all of these conditions will be false. In that case, you can apply a elif condition. If let's suppose your nums of mid, which you are getting, is somehow bigger than nums of, let's say, mid plus 1. Here is an interesting point. Now let's see who will be able to respond to me correctly in this part. For example, in this case, nums of 3. Achha, first of all, check. Is this 3 is a peak element or not? So is the first condition will be satisfied? First of all, mid is not equal to 0. First condition not valid. Mid is not equal to n minus 1. Second condition not valid. Third condition was that this 3 value should be bigger than 1. Yes, it is bigger than 1. 3 value should be bigger than 5 also. It is not bigger. So can I say this first condition of if part is not valid? So it will go to the else if condition. So in this case, our nums of mid somehow smaller than nums of mid plus 1. Can I say? Because the value of nums of mid is 3 and the value of nums of mid plus 1 is 5. Is this correct, everyone? Do you guys agree with me or not?
Yes.
In this case, when the value of nums of mid is less than nums of mid plus 1, can we get some thought ki whether our search space should go towards left side or right side? Can we decide something over here to get the peak element? Gaurav is saying traverse to right. Okay. Okay. Means
We
he
can
wants to
traverse
say
to the bigger value basically. It would be
yes.
appropriate.
Low is equals to mid plus 1. Can I assume? Means going towards the right side. So what will happen? Acha, let me complete this. In the else part, we are saying high is equals to mid minus 1. Let's see. Why is that so? If we will go towards right side, means we are working over here now. Means our low value will be updated towards 4. High will remain 6. Mid will become 5. Again, it will compare. Is this 6 value is bigger than 5? Yes. 6 value is bigger than 4? Yes. Now it will return the answer as mid, which is 5 only. And this is correct. Again, think over it logically. How we are applying a binary search because of a single constraint, which it is saying ki the peak element is the one for which the element towards right and the element towards left of that peak element will always be bigger. Means the 6 value should be bigger than 5 and 4. That's why it's a peak element. But when you are saying your value of mid is 3 And when you are saying that this 3 is somehow smaller than 5, means 3 is not a peak element, 3 is smaller than 5. What we are looking for, is a value more than 3, right? Which basically helps me to curate a peak element constraint. So it means that we have to go towards right side. So that is where we went. Think over it again. See the problem statement again. Think about the logic again. And let me know whether it's clear or not.
Yes, ma'am, it's clear. But we can have one more pick, that is 2. So how we can do that?
We can have.
There is one more pick, that is 2, in the index of 1.
Okay. So it's okay now. They have said now this thing that if you will be having multiple peaks, it's fine. You can return the index of any of the peaks that we have, right?
So this
Because
code
of
will
that only
return
we
the
can
both.
apply binary search. Binary search will give you a single peak element, not all of them. If you want all of them, that is the concern. In that case, definitely we have that big O of n wala part where we can try to store every entry, and we can take a separate data structure also to store that, and then directly we can print that in the form of a list. But because they have mentioned this particular condition, that is why we are moving towards binary search. Means we don't need to focus on all the peak values. We're just worried about any of the single peak, and that is where we can apply the values here. Your function can return either index number 1, where the peak element is 2, or index number 5, where the peak element is 6. It is clearly mentioning. But here they have specified that you have to write algorithm in logarithmic, right? So in a linear time, we can return all of them. In logarithmic time, the only possible way is to give a single result, which is given by binary search algorithm. Is that fine for everyone? Shall we try to write a code with respect to whatever logic we have understood so far, if everyone is okay?
Yes.
Let's try to write it down and then we will wrap up the session. So let's do that. First of all, we will be having a low and high value. Low value is having an index number 0. High value will have an index of length of nums minus 1, right? Now, what we can do, we can simply apply the implementation of binary search. We can do a implementation of binary search algorithm. So how can we do that? Acha, if you want, up on top of this, you can apply a base case condition that if, let's say, so one thing we can do here, we can take n variable, which is equals to length of nums, and it will be n minus 1. So we can say if the value of n is 1, means it contains single element. In that case, directly return the answer as 0. If that is not the case, we will apply a while loop where we will say low is less than equal to high. If that is the case, let's try to evaluate the value of mid as low plus high minus low divided by 2. Once we get the value of mid, let's apply the 3 conditions which we have discussed. If first condition is mid is equal to 0, mid is equal to 0, and nums of mid is somehow bigger than nums of mid plus 1. That's the condition number 1. Or second condition was if mid is equal to n minus 1 and nums of mid is somehow bigger than nums of mid minus 1, or if any one of the cases are not there, means element is a part of between array, it's on the extreme end, so we have to compare. Arr of mid is not arr, sorry, what is the array name? Nums.
Nums.
Nums of mid should be bigger than nums of mid plus 1 and nums of mid should be bigger than nums of mid minus 1. ठीक है? I hope the conditions are correct. If it is not correct, we will definitely get the error as well. If that is the case, directly we can return the answer as mid. But if that is not the case, in elif, we can apply a condition. If nums of mid is somehow, let's assume, um, what was the constraint which we have mentioned in our pseudocode? Less than, right? If the nums of mid is less than nums of mid plus 1, in that case, where are we supposed to go? Towards right side, if I'm not wrong. Low is equals to mid plus
Yes.
1. So we will explore towards right side of the array. In that case, we will say low is equals to mid plus 1. Else, we will say high is equals to mid minus 1. Let's try to run this. If we'll get some error, we'll try to resolve it. Running fine. Let's try to see. Accepted, right? Yeah. So that's the whole idea of this problem. So I'm again showcasing you, although I'll share the code part as well to everyone. And if you will observe one more thing here, because now we are using an optimized approach. So again, time complexity will come out to be log of n, and space complexity will be big O of 1. So that is the optimized version of this peak element. See this very carefully. Let me save this code and again we'll try to share with you after the class will get over. See this and tell me if you have any doubts. Make sense? Easy?
Yes.
So now you can observe, right, one thing, that no one will ask us directly implement binary search. In an interview, when you go, no one will say ki, it's a very rare scenario if anyone is asking ki, can you implement a binary search? They will give you these questions which will be solved via that approach. So that is something which we have to focus more on. Many people know what is binary search, how can we implement them. But the lag is they don't know how can we use that approach to get the optimized version of the code. One important thing, it's just a tip which you can take from my side. Whenever you feel that in companies, in technical interviews, when they are specifically focusing that array is sorted, or they are saying that you have to write an algorithm which runs in a logarithmic time. For example, you can see this kind of a statement on a lead code platform as well. In that case, make an intuition. Chances are very high that in those questions, binary search is somehow applicable. Okay, so that is the intuition which everyone should have in their head. So you can think over it that can I apply in that question binary search? And once you get that intuition, try thinking in your head that how can we go towards left or right search space, right?
Yeah, I have no doubt.
Yes.
Yeah, so actually, in my point of view, I have one doubt. So, if we get the mid number, so if number of mid less than nearby number is low, or and after number is low, so at that time we can return number of low, right?
Can you try to give me some sample example which you have in your head, and then we will see what is your query?
Yes. Suppose in this array we have 1, 2, 3, and 1.
1, 2, 3, and 1. Okay.
1. Yeah.
ठीक है.
Suppose,
Now,
yeah. Suppose we are checking. So the mid number is 3.
no. How mid number is 3 in this case? Okay, you are talking about element name, index number. Tell me index number. So
X
it will be 0 plus 3. divided by 2. So it will take the lower bound. 3 by 2 is 1. So here this is the mid value. So element is 2.
Okay.
Now
So,
tell me the question. Yeah.
oh, first,
If you want,
okay.
you can change the numbers if you want to change.
So I have on like if the if suppose we get the mid number as 3,
Okay.
so we
Let's assume
want
it
to
is
see,
3.
yeah, no,
Okay.
the
Let me
problem is
revert
Basically,
back.
we can.
I am telling I am as in my assumption I am telling.
Okay.
So
Okay.
the mid number is 3. So we want to see the right number. Right number is value is very low, which is 1. We want
ठीक
to
है.
see the left
Okay.
number. It is very low, which is 2.
Okay.
So at that time we can return 2, right?
Correct. Understanding is correct. Yep.
So any other low code is possible.
Low code meaning?
Low code meaning in this if statement we are writing very huge line, right?
No, no. See, we have to write these three conditions. What you are saying is that if, let's say, you are focusing on this specific value, it's a part where left and right is available. But when you are applying a binary search, you are keep on changing the value of low and high as per the given conditions. So if at any point of time your value of mid will come out to be these extremes, you have to handle that as well. Whatever constraint you are applying, that is true only if you will be having a left as well as right of that element available. That is the third condition. It's not that complicated if you will just try to focus here. This is something which you are saying with respect to 3 wala part. For example, you are saying 3 is bigger than 1 also, 3 is bigger than 2 also. Maybe if I write exactly, you are saying 3 is bigger than 2 also, and 3 is bigger than 1 also. So why
No, no.
not 2? I'll write only single condition. No, in that case you will miss this specific extreme conditions, right? Where, because what will happen in that case, if at any point of time your mid value will come as 0, then again it will compare what is the value of one's left. It is nothing. It will throw an error. It will throw an error. You have to specify that if, let's say, my value of mid is 0, don't focus on the left part of 1. So that error will not come. Just focus on the right part. Because how for the extreme value you will get a left? That is why they specifically have mentioned that at any point of time you are encountering this extreme constraints. Don't focus on the extreme left or right part. Consider it as a negative infinity. Means very, very small value. Just focus on only one value. That is something which you're specifying. Instead of having these two conditions, you're specifying only a single condition. That is, if you are a part of a extreme, if your element is a part of a extreme ends. If you will not write it, few test cases will be passed, but few of them where your element will lie at the extreme ends will not be passed. That's the problem. For example, if I'll give you one sample test case for the same, for example, let's say we will be having an element 3, 1, 2, and let's say 2 itself. Now, if I'll ask you, what is the peak element in this case? What is the answer?
3.
It is 3 actually, right? How will that condition where you are just comparing the element to the left and right will tackle this case? It will not tackle, right? So, because if you, it will see 1, it is not a peak element, 2, not, 2, not. 3 is a peak element. So we are saying, don't focus on the left part, just focus on the right part. You are bigger than that, print that. That's it. So here the answer will be actually index number, which is 0. 3 is the peak element. So to tackle those instances, those test cases, we have to write that conditions as well. Does that make sense now?
Yeah, got it.